Hello, my name is April Flores. Today I'll be presenting my final project for the traveling salesman problem applied to a road trip for MIMS 5001. The objective and scope for this project is to apply the traveling salesman problem to a cross-country road trip in the United States. The traveling salesman problem is a graph theory problem that searches for the shortest Hamiltonian cycle, i.e., the shortest path of travel to each defined location exactly once. This project has three main components: the traveling salesman optimization, a distance matrix considering roads and geography, and last, a map visualization output. Due to time limitations, the lottery aspect of the Kanab, Utah destination was not included. This aspect was considered before the traveling salesman problem was understood. By not including this aspect, the overall deliverables were not impacted. To better understand the traveling salesman problem, a background and related work was researched to better understand. The traveling salesman is considered a classic discrete optimization grouping problem, which is widely used in practical applications. The traveling salesman problem is defined as an NP-hard problem, which is intensely studied problem in optimization. In the 19th century, the traveling salesman problem was mathematically formulated by two mathematicians, but it wasn't until the 1930s that the general form of the traveling salesman was studied by Carl Menger, who developed the brute force algorithm. This methodology calculates and compares all possible permutations of the possible routes to determine which route is the shortest optimal solution. For routes of 10 destinations or less, this method is reasonable. For the model summary, the software and resources used for this project were MATLAB and the Google Cloud Platform. The traveling salesman optimization uses the brute force algorithm. This algorithm is known to have limitations which are discussed in more detail in the continuing work section of the final report for this project. The distance matrix has been extracted using the Distance Matrix API in the Google Cloud Platform. General guidance and interfacing with the Google Cloud Platform through MATLAB can be found in the appendix of this presentation. Due to time constraints of this presentation, the general guidance will not be covered in the playlist video. The map visualization output has been extracted from the Google Cloud Platform using the Maps Static API. The model results are summarized on this page. The farthest left table is the MATLAB entries with all the destinations. The top middle table is the optimized route generated using the brute force algorithm. The bottom middle table shows the distance between each destination in the optimized route with a total distance of 5,480.5 miles. The leftmost image has been generated in MATLAB by extracting an image from Google Maps and overlaying the coordinates of each destination on top of the image. Note that the optimized order shown in this image is also valid in the reverse order. The total runtime was roughly 3.5 seconds. To validate this model, I've used the optimized route generated in MATLAB as inputs into Google Maps. The resulting distance in Google Maps match the total distance in miles calculated in MATLAB. References used in this presentation. This concludes my final presentation for MIMS 5001.